6 or 7 years ago, maybe 6 years ago, I wrote this article for when I was working with the Raspberry Pi Foundation for their education magazine. And it was an attempt to try and explain what I'm doing. And it was, the title was Live Coding Education. And I started off with this paragraph here, and I'll just read it out. So, the lights sliced through the mist as the rhythms moved the crowd. The atmosphere was ripe with a heady mix of synths. However, something wasn't quite right. Projected in bright colors above the performer was futuristic text, moving, dancing, flashing. This wasn't fancy visuals. It was merely a projection of the free live coding system, Sonic Pi. The musician wasn't spinning disks. She was writing, editing, and evaluating code. Live. This is live coding. Then I went on to say this might sound like a far-fetched scene from a futuristic music festival, but it's actually a description of a pupil performing at their primary school, in their assembly, and coding this as going trends. And this is how I introduced and tried to frame the work I'm doing for, and this was specifically for teachers to read and understand. And I go on, show a projection of me performing and talk about code and music and things. And I won't spend more time on this article. More to say is, I wrote this paragraph 6 years ago, as I said, and then I was kind of describing this kind of scene. I don't know if this is quite clear to you, of like a person, she's performing, she's a DJ on stage, there's a big crowd, and this is real. This is in New York. It's like last year. This is DJ Dave. And it's ripe with a heady mix of synths. There's lasers flashing, there's lights going on, there's code projected behind her. And that code isn't visuals. I mean, I did a performance, so the reason why I wrote that, I did a performance many years ago with an older system I was working with called Overtone, which was implemented in Clojure. And I got actually reviewed in a magazine, and it was a very nice review and very positive. The words about the sounds I was making, which I was very pleased about, and talked about the fact I was referencing other synthesizer people which I'd never heard of. I was like, okay, I'll read about those. But also it said, great visuals, you know? And I was like, oh. It's kind of like going to see a Jimi Hendrix concert, which we obviously can't, but imagine if you could, right? And going, great wooden medallion. Like, I don't know why he was wearing that massive wooden thing around his neck and playing with it, but it looked cool, so I'm going to write that in my review. And, of course, if you've never, ever seen a guitarist or a guitar, going to see a live guitarist perform is going to be a really, really weird experience. Yeah, I'm actually super excited and intrigued to understand what's going on in the minds of all of these people at this gig and all of the gigs that DJ Dave performs at around the world. Because think about it, like in terms of programming, how many people in the real world that aren't strange programmer people like ourselves, how many of them have actually seen real programmers program? Not many, I don't think. Like, the experience probably most people get of real programmers programming is films. And we've all seen the films, you know, like scenes where there's spinning cubes and the matrix is flowing down, you know, and everyone's like super fast typing, when in reality, most people programming are going, like this. Why is it not working? Why are my types not checking? Right? Obviously, this is the kind of audience, that's what you'll be doing most of the time. But I'm still going, why is it not working? And so, for these people, they're actually experiencing a real programmer, a professional programmer, she's a professional programmer, performing, and their experience of what code is, I deeply hope, is reframed as not just something that's a tool for business, but as something as a tool for human expression. And I think that's really, ultimately, what I'm trying to do. And I've spent the last sort of 10 years working on this system, trying to figure out what it is I'm doing and why. And it initially started as a response to a challenge when the Raspberry Pi computer came out. And I was working at the University of Cambridge in the computer laboratory, and that's where it sort of span out of. And there was a little bit of money going around, and I just finished my contract for my postdoc, and I was about to go back to working in industry. And there was a sort of a little bit of money for somebody to build something which could possibly engage children in computer science, and they ran on the Raspberry Pi, because this little computer, although it was super cool and super cheap, it was also super slow. And no education software really ran on it very well. Like Scratch, for example, which back then was implemented in Smalltalk, was really, really slow. I remember they had to hire people to optimize it to actually run on the Raspberry Pi. And so they were interested in something that specifically targeted that. I'd been working on this other system called Overtone, which was my attempt to build the most crazy, powerful live coding system I could imagine. It was a project with a friend called Jeff Rose. So Jeff started the project, and then I took it over. And this was an implementation of a programming language using Clojure and talked to this really fancy synthesis engine called SuperCollider. And SuperCollider is kind of like Nginx, but it doesn't serve web pages, it makes sounds, which is way cooler, right? Well, you're going to use Nginx or SuperCollider? SuperCollider. I mean, and it's very similar. Like with SuperCollider, it's a process which runs in the background. It doesn't have an interface, the server process that is, and it has an API, a network API, and you send network messages to it to tell it new designs of synthesizers, control messages to trigger synthesizers, to manipulate them, to move them around in what's called the node tree, which controls the order of execution and lets you modify things. It's a really powerful system. And so I built this overtone system initially as an attempt to build something that I could perform with, like it was my own tool, because I'd been to these conferences before, and I'd gone to the parties afterwards, and often there would be like a band of Java programmers, and there'll be like a Java guitarist and a Java singer and drummer. And they'd never met each other before, and it was like quite fun to see them perform, but it was like, come on, surely we're all programmers, surely we should be programming the music. This was my initial idea. That was like 15 years ago, and it's only now I'm starting to realize it's possible. It's taken me a long time. But of course, there's many other people who've been working on music and code. I'm certainly not the first, and I certainly won't be the last. In fact, if you even look back as far as like Ada Lovelace, she was talking about how, she was imagining these computers which didn't even exist yet. They were just formalizing the ideas, working on these mechanical engines that were turning around and doing sort of interesting mathematic computations. But she was able to sort of see this machine, which was just doing numerical computations primarily, and imagine and extrapolate what it could be, abstract it to a system that could actually start to do all sorts of interesting things. And she specifically talked about these computers of the future being able to make music of our dreams. And we're at the time now, we're at that point where that's really amazingly possible. I mean, we were at that point almost like 80 years ago, really. There were people making music in the 50s, but on one computer where each city only had one computer, and it was obviously like millions of pounds worth of computer, and try and find some time to work on the computer to make music versus doing business applications was obviously a really hard problem to deal with. But people did do it, and people did make them play like Bar Bar Black Sheep and interesting melodies on these massive room-sized computers. But today, we're at the point where we can run it on a Raspberry Pi, and that's interesting in terms of accessibility. And so, coming all around to all of this, I think that I've started in a way that's trying to frame it in a different way. But I really want to try and emphasize the point that programming is not a tool just for business, and it's a tool for expression. And I want to talk to you about why I think that's a really important thing. And I'll move away from this overtone in terms of, let's go back to DJ Dave. Why that's important, because the challenge I had when I started working on Sonic Pi alongside the Raspberry Pi Foundation was to find something that could engage kids in coding. And, actually just this week, I saw a tweet from a very eminent professor in America, Mark Gusdale. He's a professor who talks about computer science and education. And I can't remember the exact figure, but it's something like 4% or 3% or 5% of kids in America choose computer science. That's terrible, isn't it? How terrible is that? They're obviously probably quite likely to be self-selected, which probably means that they're not very diverse. And this is a real problem in our communities, and something we absolutely need to face. And people are working on tools and techniques that can help increase efficacy of the education process for computer science. That's super interesting. But I think that if only like sort of a single-digit percentage of people are choosing to do it, The bigger question, I think, is how on earth do we get that to be double digits at least? How do we get it to be everybody? And we had this problem in the UK. So whilst I was working on Sonic Pi originally, that was the same time that Simon Peyton-Jones, he formed a group called CAS, Computing at Schools, and they lobbied the government in the UK to create a new computer science curriculum. And they were really successful. It was amazing. And so the government created this curriculum. Suddenly, teachers were now faced with the challenge of teaching computer science and algorithms and data structures and conditionals and all that kind of good stuff. But they also had the same problem of, well, we don't really have any educational material for this yet, so we need to create some. So what do? I mean, I'll tell you the titles of some of these things, but my imagination is they went to people like Simon and said, basically old guys with white beards, and they said to them, old man, what got you excited about programming? And they would go, ooh, stroke the beards, ooh. Sorting algorithms. Yeah, sorting algorithms. Oh, cool. Well, I don't know. What else? Oh, binary. Oh, okay, right, binary. Right, great. And so they came up with titles, right? I made that up, right? That was made up. But this is not made up, right? There was a scheme of work called, and it's like kind of some sort of like a drug kind of thing, like give binary a try. Because obviously, once you've tried binary, you're never going to stop, right? You're going to be hooked forever, So it's like too many coffees or something. And then the other one was the best I've ever seen, actually. It started off really well, right? It said, have fun. Okay, that's great. That sounds like it's very enticing. Have fun with sorting. I mean, actually, you probably, all of you, I'm sure, have fun with sorting because you're weird programmers like me, and that's the kind of thing we like to do. But we're that sort of 3%. How do we engage the other 97%? And I don't think sorting is the way to do that. I don't think binary arithmetic is the way to do that. In fact, I think most of the things that we probably find interesting intrinsically about programming is not the way to do that. Because we're not talking to ourselves, we're talking to everybody else who's not in this room, the people in the streets we walk past to come to the conference. How do we engage them in programming? And I think this, to me, is a great vehicle for that. It's a great tool to show that programming is something for them. So when I went into classrooms, one of the challenges was, initially, build a piece of software that can help kids learn to code. And I was like, okay, great, what's the time frame? 3 months. Whew. Okay, right. And so I went to this meeting to discuss, I had this idea, I'd take this overtone project, take the smallest subset of it I could build that I could use then to deliver the content. And in this meeting around the table, these professors like, so, yes, you're going to make a piece of software, you're going to find a teacher, you're going to go into a school, you're going to deliver lessons, you're going to write some lessons, and you're going to deliver the lessons and evaluate it in 3 months. So I was like, this is ridiculous. So I cancelled all the things I was doing and focused on it. And obviously I had to make the smallest possible thing I could work. And so that I cut off all the bells and whistles and made something really, really simple. And when I went into classrooms, it was really amazing to see how, because we didn't really know what we were doing. I was collaborating with this fabulous teacher called Carrie-Anne Philbin, and we didn't really know how to use this, because it was all new for us, and there was this Sonic Pi thing I just built. It literally took me 2 weeks to build the first prototype, which we then used in the classroom. And then the development was, we'd discuss what we were going to teach, we would spend the hour teaching it, and then we'd spend an hour sort of deconstructing and figuring out what worked out, what went wrong. We'd then discuss what we're going to do the next week, then I would go home and then write the next version of Sonic Pi, and go and deliver, which had the features for the next lesson. So every week there was a new version of Sonic Pi, which meant actually on the Raspberry Pi, and because we had like 30 kids, I had to flash 30 SD cards every week. That was a nightmare. I really dreamed of those machines, you could put all the SD cards in and flash them all at once, but they were thousands of pounds, and I couldn't have one of those. But what was really interesting is that the kids, we had one lesson which was variables, because variables was on the curriculum, right? And the teacher said, yeah, we need to teach variables, cool, right? So we taught variables, and so the kids would write these, where's my editor, right? This kind of thing, great, I've got a variable called A, that's cool. But actually, loads of them do things like Justin Bieber equals 99. I've got a variable, and the teacher could tick the box to say the kids have learned about variables, right, because they've made some. But they didn't know what the hell they were doing, or why they were doing it, or what the relevance was to their lives at all. And this is, I think, actually an endemic problem in education, is that so often, certainly in the UK, I don't know what it's like in Poland, I'd be interested to find out, but certainly in the UK, the kids are very aware that they're in this context where there is the curriculum and there are things to learn, right? There are, what are the learning objectives of today's lesson? And all they care about is jumping through those hoops, right? And they've ticked off the learning things, they've done it, and they can go outside and play. And so they don't really care about why they're doing it. They just know they have to. And the parents say, you need to do well at school, because if you don't do well at school, you can't go to the next level of education, or you might limit your job opportunities. So all they're doing is they're trying their best to jump through these hoops. So there's the kids jumping through the hoops of variables. It was rubbish. And so we sat down, and I put my hands on my head, like, this is terrible, it's not working out. But it soon worked out that as soon as you didn't do variables, but you did something which was meaningful to the kids, then they actually got it. So this is what this article talks about over here. So instead of sequences, we do melodies. Instead of iteration, we do rhythms. Instead of we do selecting sounds for randomization, and we do where was another one thing? So yes. Yeah, using the constructs of the computing, mapping them into music, actually made the concept much more engaging and interesting to the students. And that was a beautiful thing. So this is something I've spent more and more time on, focusing on how to make this easier and more accessible, and trying to find ways to get kids to use this. And then also to answer that question I asked earlier, why would they bother? And I think starting with a video of someone like DJ Dave is a really, really great critical tool. And it's important to talk about the fact that this idea of music as coding music as a vehicle for education isn't just constrained to the sort of social context that we normally walk around in. There was an amazing project called Codebus Africa. And this wonderful group from Finland took a bus around a whole bunch of African countries and used Sonic Pi to deliver computer science lessons to over 2,000 African, predominantly female women and girls. And so part of that is they made this wonderful video. So it's sort of 15 minutes long, so I'm not going to play it all. But I was going to play this quick short section because I thought it was really beautiful. So here are two girls in one of the Sonic Pi lessons discussing their composition. And they're having a sort of interesting chat about it. Let me just watch it.
So before this,
More bass. This is one of the compositions one of the students made. Facial expressions. So you can see here that those facial expressions are wonderful. They're engaged, they're interested, they're focusing on what they're doing. And they're not programming, they're making music. They just happen to be programming. And that, to me, is the interesting sort of inversion of what's going on here. So for me, this is a really exciting thing to see crossing these cultural boundaries and effortlessly. And I was a bit concerned initially, but it's just beautiful to see. And I mean, there was a lady in Canada, and she made an opera with my software. And there was a lady in India. She made some beautiful Indian music and programmed her own scales that weren't in the sort of normal Sonic Pi system, and extended it in ways that were culturally resonant to her. And that was, I think, a beautiful thing. So there we all go. I'm trying to paint the background and the picture of what I'm doing, what's going on. But it's important to spend a bit of time talking about the software, because I think this is interesting. Because I'm going to give you a tool, right, to help you, because there's a challenge, right? I always say this when I go to a conference, because I find it humorous myself, which is, how many of you go to parties? Like a few of you, right? Yeah, it's okay. So, yeah, I used to do that, but now I've got kids, right? So I don't really go to parties anymore. But when you go to parties, right, this is a serious point. How many of you talk about the fact you're a programmer at the parties? I mean, obviously, like last night's party, that's going to be the entire conversation, but that's not a normal party with normal people from the streets. You go to a party with the people on the street, then you say, "Hi, my name's Sam, what do you do? I'm a programmer." Ooh. Okay. And they're off like this. And so I don't do that anymore, I lie. What do you do? "Hi, I'm Sam, what do you do?" "I'm a musician." "Oh, cool. What do you play?" "Code. I play code." "Oh, okay, how does that work?" And then they're interested, right? They've got a point that's meaningful to them, and the conversation could start, right? So this is a critical thing. So what I'm going to show you is how Sonic Pi works in the remaining of my talk. Merely as a tool for you to lie when you go to parties and pretend that you're cool and you're a musician, because then you can have conversations. And we all want more conversations. And it's not just a benefit for you to have a conversation, it benefits others to talk to you about programming, because that's something that's very hard to do. Because even if you said, "Hi, I'm a programmer," and they go, "Oh, okay, so what do you program?" "Well, I program," you can insert whatever it is, strange, esoteric context you're programming in with whatever type system theories or AGDA things or some compilation thing or some LLVM, whatever it is. No one's going to listen to that, right? Because they have no frame of reference. Because people haven't even seen real coders, as I said before. They don't even know what real programming is, never mind the sophisticated kind of programs that you might write today. So this is a way to help that conversation, to help reframe programming, because really, 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 really it's important, for me at least, to try and communicate to you the message that programming is not just for business. In the same way that reading and writing isn't just for religious tomes and legal documents, which is what it was originally used predominantly for, right? Predominantly, people who wrote were very, very eminent people in religious circles who used to write their tomes, or legal people writing contracts. And so you'd hear stories about companies or organizations going and buying farmlands, and the people can't sign the contracts. All they can do is put a cross, because they don't even know how to write. So there was a time where reading and writing was a very elitist activity. And obviously today, we laugh and scoff at that, because of course, reading and writing is not just for legal documents or religious tomes. It's for writing weird emoji text messages to your friends, obviously, isn't it? It's for writing to-do lists and shopping lists, or for writing poems, or writing books, or for writing all sorts of beautiful human expressions. Is code only just for business? Today, predominantly, yes. And I think that's something I feel quite sad about that, to be honest. And I think that's something I'm striving to try and change. And I think in a party context, that's how you can have that conversation, and that's how we can engage the next generation of kids to program, is to actually reframe programming, not just as a tool for business, which of course it is, but also as an amazing, unexplored, predominantly, tool for human expression. So, this is my attempt to make a tool for human expression. It's a software called Sonic Pi. I was flicking around on the website earlier. Here's the website. You can download it. It's totally free. It runs on Mac. It runs on Windows. You can also run it on a Raspberry Pi. We've got Debian builds for that. There's also Ubuntu builds. And then the Linux compile story is much better than it ever has been. And there are package managers and maintainers, popping up everywhere. So if any of you are interested in helping to maintain Linux packages for Sonic Pi, please talk to me. I'll be super excited to talk to you. And yeah, you just download it, and you open it up, and you get this editor. And of course, you can run some variables, but obviously that doesn't do anything, because it's rubbish and boring. No one wants variables. What do we want? We want to have sounds. So you can write the word sample, and you can choose one of the sounds. Let's choose one of the sounds. Let's go for loop amen, and let's make it loud. Cool. Right, so that's a lot of people's first program is making some sounds, a single line of code. Sorry, there's no static typing. But then a lot of these things is like there's no test first stuff, you know. But a lot of this is about trying to reduce that barrier to entry for the first programming experience. It's not about writing software which is going to run massive machines and all sorts of complicated computations that's designed to run 24/7. This is just a tool for writing ephemeral programs. And this is another important point, and I'll probably come back to this later. But you've got to think about it in terms of when you think about language A, is Haskell better than Scala? Obviously, you'll all have your opinions, right? Is F# better than C#? Well, you're going to have your opinions, right? But often you don't think about that in a sense often those conversations are expressed in a timeless manner. So there's an implicit, given an infinite amount of time, is language A better than language B? Like, can I express a solution in language A more elegantly or more clearly or more robustly or maybe more formally provably in language A than language B? And that's a really interesting thing to think about, and I think that's predominantly the way these sort of arguments and discussions are held. But if we don't make that assumption, if we say, given 20 seconds, what are the range of programs you can write in language A versus language B, you're going to get a very, very different answer. Now, you might say, who writes a program in 20 seconds? Well, what on earth is that rubbish? It can't be any kind of a decent program. But of course, like, you might have been in a situation where you're sitting in a meeting and the client's asking you a question about the business, and they're like, so how many users are actually doing this? And you're like, don't know, actually. You open up the REPL, you put an SQL query in, or whatever it is, and you're like, brrr. You think, I'm not quite sure, because I'm just throwing this in the database, but it's around 2,000, right? And like, oh, cool, let's look into that, let's put a team on that, right? That's an interesting thing. Or, well, that's not interesting. You might ask another question, another question, another question. And when you get to an interesting result, you might then dedicate a team on that. And so if your question and response takes days, you're not going to ask as many questions. And you're not going to necessarily get to ask the interesting questions because you're going to ask the ones you think are going to be important. But often, the really interesting ones are the ones you just randomly try, and then you're surprised. Oh, that's a shock. And then I'll put a team on that. So those contexts are what I'm talking about. But also, DJ Dave, when she's performing, or when I perform like last night, literally I get 20 seconds to write my next program. And so when you're expressing yourself, again, that very fast feedback is very important. So this is a really critical thing. How do we get to a very quick point? And also in education. When you go into a school and you say, well, we're going to learn computer science. What do we do, sir? What's the first thing we do? Open up IntelliJ, or whatever it is these days. Or is it VS Code? That's the one everyone uses. I mean, if I say open up Emacs, that's never going to go down well. So again, like, and then even then when you open up VS Code, you've got to create a project, you've got to sort your class paths out, or your environment variables, or whatever it is, your build tool that you're using, install cargo, whatever it is. And so there's a whole ton of ceremony that goes, and we all know this, when you have a new person joining your team, how long does it get them to be set up with the environments? Sometimes it can take a large amount of effort. So again, it's about super quick, super fast to your first program. Okay, so now what do you want to do? So the kids are asking all sorts of interesting questions. Well, we might want to play a different sample. Let's play like a choir. Cool. Make it louder. Maybe you want to change the pitch of it. Ooh, or maybe like low. Or maybe like, let's go minus 23. Nice, like monks singing, right? And you can see I'm just playing around. I don't need to know what the numbers necessarily mean. I can explore them, and through the exploration, I can get kind of an understanding, like a tacit understanding of what's going on. What's interesting here, you probably haven't recognized, is that, did you hear that the sounds overlap? So we already have, without even talking about it, we have a concurrent environment. So every time I press the run button to trigger the code, it creates a new thread to execute that code in the context of that thread. And if I press the run button again, it creates another thread, so they're running concurrently. And we'll get to that, why that's really important very, very quickly, because in music, concurrency is the norm. It's the simple form. So that's quite fun. So and of course, there's a bunch of samples built into Sonic Pi. They're all Creative Commons Zero licensed. They're not necessarily very good, because it's really, really hard to get artists to put their audio samples in a Creative Commons Zero license. They always want to get attribution, which is totally, totally understandable. But the goal with Sonic Pi is it needs to be free, and if you make something really cool, you need to be able to have ownership of that yourself. It's really a critical thing. But you can also download or record your own samples, your own sound files, and play those and manipulate those just as easily as you can with the built-in ones. Instead of putting ambi-choir, you put a string with a full path to a WAV, FLAC, AIF, OGG file, and it will play that for you. But what else can you do? So the kids would do things like this. So they would, let's get into that in a second. So you can also play notes. Ooh. That's good. And then you maybe want to play 2 notes. So the kids would write this, and this is an interesting thing to think about. The way to learn Sonic Pi is to look at the code and don't press the run button, but to imagine what it's going to sound like. So let's all try that for a moment. Imagine what this is going to sound like. 76 followed by 79. Ooh, they played at the same time. That's interesting. That's because the execution model of Sonic Pi is unlike most programming languages you've come across, because it's a language model for music, not for numerical computation or something like this. But also originally, this was actually executed sequentially, and of course computers are fast, so it's going to play the first line before the second line, but only a very small difference. And that was timing model 1 of Sonic Pi was that. But that turned out to be a real problem when you had multiple things playing at the same time, because the times, they weren't the same. Because when you ask a scheduler to sleep for 1 second, it will sleep for at least 1 second and a bit more. And that a bit more is non-deterministic. It's totally dependent on the speed of the CPU, the load of the computer, the operating system, what it's doing. And so that extra delta times, they added up. I did say I wasn't going to talk about types and all that kind of stuff, but just quick throw this around. Have I got a link to it? Oh, it's on the... I thought I made a... There we are. I did write a cool paper with a really amazing chap called Dominic Orchard, who's a really cool guy. I describe all the time system I'm describing now, where you can play these notes, and these deltas, they all add up, and they cause drift in the audio. And so timing model 2 I implemented was to counter for that. So what happens is the code executes ahead of time. It sends well-timed messages to the supercollider system for when it should actually execute, and then the supercollider system schedules those messages to happen on time. So, and this paper describes it, and we've also got some cool proofs to demonstrate that the model is sound as well. So if you're interested in that kind of thing, I recommend that you read and understand how the timing model works. But effectively, what we're doing is we're creating 2 messages on the network ahead of time with timestamps. So these are actually executed concurrently at the same time, sample accurately. So that's 1/44,100ths of a second at the same time. Actually, it's not quite right, because you've got the block size of the audio card that can make slight differences, but very, very close to the same time. So we need one more command, that's sleep, and then we can split them out. So that tells the computer to play note 76, wait for a second, and then play note 79. And at this point, this sounds very, very simple and simplistic, and you think, why are you showing me this, Sam? This is not DJ Dave performing on stage. But these 2 functions, sleep and play, are all you need to reproduce any classical piece of music, to make any melody, any bass riff that's ever been written or ever can be written. Okay, it's a simplified form. It's with a sine wave. It's a very simple timbre. But if you look at the essence of Western notation, at least, you've got the height of the stave which note to play, a high note or a low note, and then you've got the timings of the notes. And with these two functions, you have exactly that. So you can choose whatever note you want, or whatever duration of note between which note, and then you can also play concurrent notes by not putting a sleep, as we saw before, and you can reproduce any melody. And this is great because kids just love it. I gave it to my 6-year-old niece, and she programmed 100 lines of code on her first program. I was like, that's amazing. She said, Sam, I am not finished yet. She carried on making the melody. So this is great. And so already without getting started, you can do quite fun stuff. Of course, then, you might want to do other things. So let's go back to the samples again. Let's go for sample bass drum house. That's great. Let's make it a bit louder. Put a bit of low-pass filter on it. Yeah, that's quite nice. And then you might want to repeat this thing, right? So you'd do something like this, and then sleep for 1, and then like this, and then like this, and I go, oh, okay, I'm going to cut and paste this now. And I've got my, oh, it's slow, isn't it? That's so annoying. I want to make it faster. So, oh, this is annoying, right? Okay, sorry about this. Well, obviously, kids do that, right? And I've seen education things saying that you shouldn't do duplication like this. It's a bad form. It's not. This is brilliant. Kids can understand this, and they work with this. And then when they get annoyed, like I just got annoyed because I've got to change all those 1s to a half to make it faster, then I've got a motivation for something better. Then it's important to me. If I start with the end point, you can use iteration, or you can use loops, or you can use recursion, or tail recursion, or whatever. You can use continuations, right? That's not good, because the kids don't know what the hell they are, those things. But when they've written something themselves that has a level of complexity that starts to annoy them, then the tools of abstraction become useful and meaningful to them. And then they will learn them. And then they will suck these things into their bodies because it's important. So you say, okay, right, what you can do is you can put it in either iteration. So this is actually, this language I'm using here is a DSL inside of Ruby. So I can do this. So obviously now if I want to make it faster, I can do this. Great. I've got my nightclub going, and I'm going for, it's rubbish, it stopped. So this is where you can start. So this is again, you can say, okay, you could put this will totally work. Kids do that, and that's totally fine. But there's actually nicer tools for this. Obviously, you can just do a loop like this, and now you've got your kick drum for your nightclub. Great, we've started. So what else do we want? So the kids are like, sir, how do I make some bass? So okay, right. So let's just comment this out a second, and let's try some bass samples, like a bass, like this one. It's a pretty good one. Yeah, let's use that. Yeah. So let's put that in a loop. And let's sleep for 2 seconds. Yeah, that's good, right, that's cool. And then let's get this going at the same time. Oh. So this is actually a good interview question. Why can't we hear the kick drum at the same time as the bass? I'm assuming all of you know the answer to this. But kids don't, and teachers don't either. Because teachers got loops on the curriculum, so we're doing that. Cool. But the kids, they write this. They really write this after a couple of hours. Right? Because they know loops, and they've got a loop for the kick drum. So, okay, I'll have something else. And they'll add another loop. And so you go to them, and they put their hand up. Why can't I hear the kick drum? Have I made a code error? And I'm like, no, that's totally valid code. But it's never going to work. And why is that? Well, obviously, the code starts at the top. The loop is infinite, it never gets out of that loop, so you never get to the second loop. You never hear the bass. I'm like, well, that's a bit rubbish, isn't it? This is not a very good musical system. You're like, no, it's not, is it really? But this is obviously in the early days, right? And so this was the point where I'd be always meeting these things like that, and then I'd say to the teacher, the kids want to be able to do this. I can modify the system to allow them to do that. So I said to the teacher, the kids want to play the drums at the same time as the bass. Oh, yeah, of course I do, yeah. And so I said to them, next week, can we teach them how to do that? And then she said, is it on the curriculum? I'm like, well, it's concurrency, let's have a look. Got conditionals, variables, iteration, algorithms, whatever they are, that's a very abstract term, data structures. No, there's no concurrency on the computer science curriculum in the UK. And so the teacher would say, sorry, We can't. We can only teach what's on the curriculum because we've got to focus on this because the learning objectives are there and the curriculum's there and the assessors will come in and assess it. And I didn't say this to a child, but I wish I did because it's a really nice way of framing it. But I went to this girl because the girl was trying to do this and I said to her, terribly sorry, can't do that. But if you want to do that, you have to wait till you're 18. And she's like, yeah, if you wait till you're 18 and you still want to do it, then you can go to universities. And they will teach you these things, the concurrency things, and you can learn it. And at this point, like obviously the girl's like, she looks out the window, she's switched off, because she's worked on something that was interesting to her, but then she's found a really arbitrary, annoying limitation that shouldn't be there. Because clearly, if you're making a musical instrument, surely this should work. Okay, it's within the confines of the computer science curriculum. Loops are infinite, and they don't come out of them. But surely we can fix this, right? So this is what I did. I was like, kids want to do this. Teachers don't want to teach concurrency. So let's just sneak it in. So you don't do loops in Sonic Pi. You do what's called live loops. They need to have a name. So this is Claire. And this one here. This one's Kate. So now we have our two musicians. And when we play our code, yeah, it's working. So that bass is a bit loud. So let's just make it a bit quieter. That's pretty good. Maybe you want to make the drums faster. Maybe you want to comment the drums out. Maybe bring the drums back in again. Like this, right? So the live loop not only does the concurrency thing I talked about, it does a few other cool tricks as well, which you probably just noticed. One is that it does hot swapping of code, so I can modify it as it's executing, which is quite fun, probably not that exciting to you. But the other one, which you probably haven't actually yet understood, if you have, I would like to talk to you more, is that these threads, they're not just concurrent in the traditional sense of executing at the same time. Because that wouldn't make sense, right? In a band, you don't, unless you're in a free-form jazz band, right? Then you just want a load of people with weird instruments just to do their thing, close their eyes, feel the music, not look at each other, not care necessarily what each other are doing. That's cool, right? That's totally fine. But often, you might want them to play in time with each other. Usually that's what you want, actually. And so these threads don't just play at the same time. Did you notice they were in time? And even when I modify the timestamps, or the sleep times, they also actually worked in time. So I put a lot of effort, that's what that paper describes, the timing system, to make sure that even in a concurrent situation, these threads would actually work in time, and they will stay in time forever. And you can do really cool things, like you can start a new thread and get it to use thread barrier synchronization to execute in time with an existing running thread, which is what you want to do a lot when you're making music. You start the threads up, and you build it all up, and take things down. And of course, you make mistakes. And if you make a mistake in a thread, like this thread here, if I make a mistake, it just kills that one thread, right? And so I can bring it back in. I can say, when you start, synchronize with Claire. So now it's going to wait for Claire to go around, and it comes back in, right? So we have this kind of fun stuff. So these kind of cool tricks which make performance possible. So this is getting towards what DJ Dave might use on a performance. And then at this point, we were able to teach all of the UK basic computer science techniques. You can imagine how you can do iteration and data structures, of lists of notes to play and stuff like that. But actually what I noticed was the challenge of getting the kids to be engaged was the hardest one. Because kids would ask all sorts of interesting musical questions, like how do I make this sound like it's in a big room? Because obviously maybe they've got a friend with a guitar, and a guitar will have a guitar effects pedal that does reverb or distortion or a flanger or all crushing the sound in interesting ways. And so they're like, how do I do that? And this is a problem, right? Because in traditional, so the Sonic Pi is one of many live coding systems, many music systems. It's based on a system called SuperColor, as I mentioned before. SuperColor has its own cool language for designing sounds and manipulating sounds. But it's much more low level, and you have to understand semantics of much more stuff to get anything done. And what you would normally do with a reverb is like somehow construct some sort of reverb like this. So SuperClire is like a small talk-based language, so you've got objects and constructions. And then you then would say, okay, right, now I maybe want to then play my sound, but you probably have some weird, Haskell people will probably love this, like some weird operator, to then pipe it to R. And then, which is pretty cool, right? So now I've created my reverb, I'm piping my sound into my reverb, which is pretty cool. But then I have to somehow destroy the reverb, because what happens if I do something like this? Right, and now I've got like 100 reverbs, and they're all consuming the memory in the CPU, and well, actually not memory, CPU predominantly. And so this is a problem. So somehow you have to like figure out when to kill R. How do I destroy? How do I garbage collect the synthesizers? So this is one of the reasons why we couldn't teach like effects in a computer science lesson, because it's not on the curriculum. You know, and even if it was, even if like objects and constructors and pipings and destructors were all on the curriculum, this is like 5 lessons at least before kids can actually even get to use this. It's so much to learn, to understand, just even that snippet of code. It's just not even possible. So again, a lot of what Sonic Pi is about is trying to figure out how do we do that? You know, how do we do a way that the kids don't need to know actually what they're doing? So if the kids have like some iteration like this and they're playing notes, you can also use traditional Western notation. Let's go for E3. Let's make it a short note. Let's sleep for a short amount of time. Let's go for like E5. Or maybe let's play like octs. I like Lisps, so I always put the parenthesis in the front for these things. So this is a vector-like data structure, an immutable data structure which represents a set of octaves. I'm going to tick through those. Cool. Now, when the kids write something like, they're not going to write this, I'm just making that because it's quite a succinct way of writing something interesting. They might want to add some reverb to this. So you just use lexical closures. So I'm going to create a lexical closure around the whole context I would like to apply my reverb to. And say with effects, reverb. I might specify some parameters like the room size to be 1, and now I have my reverb. And this will automatically create the reverb for me, it'll automatically do all the piping, and more importantly, it will figure out when to destroy the reverb. Because, I mean, the critical question is like, when do you destroy it? Do you wait for the electrical closure to complete? No, because the synthesizers might be long-lasting, and if you kill them whilst they're still playing, that's not cool. But even then, if you wait for all the synthesizers to complete, which you have to do, so you have to like register and watch all the IDs that are created and make sure that they're completed, you could also, inside the lexical closure, you could spawn threads. And that thread might like sleep for a minute before it starts making the music. So not only do you have to wait for all the synthesizers to complete, before that you have to wait for all the threads that you spawned to execute. Which then means you have to track the threads that the threads create and the threads that the threads that the threads create. So you're creating these kind of trees of threads, and you're watching over them, and it's, to Erlang people, might sound quite familiar. And obviously, I implemented all this in really bad Ruby, and I'm quite ashamed about it, but it works. And so I think actually moving this onto the Beam is going to be a much more exciting proposition. But ultimately, this works, and it's a really nice way in a lesson to sort of go, hey, just add like this thing with effects reverb, do, and end. Wherever in the code you want it, and it will automatically do all the right thing for you. So this was a cool thing. And another cool thing, I've got like 10 minutes left, good, was to think about how to actually do interesting musical things. Like, so a lot of the music I listened to, well, in the 90s particularly, was like drum and bassy, techno-y music. And these are musical compositions that were enabled through technology, and the technology around at the time allowed them to use like magic scissors on the samples and to stretch and to shrink the samples in interesting ways. So what do I mean by that? Well, let's just go back to this Amen break. So this is cool, this Amen break. It's culturally super relevant and important. It was recorded in the 60s, I think, by a band called the Winston Brothers, and it was released on a CD that was given to artists for free for samplers to use. And it was just a random drum sample from a B-side of one of their tracks. And it's like this. Now, this was cool because you could the samplers of the day, you could like change the rate of the playback. And so Dr. Dre used this in his first album, half speed, and rapped over the top. So we might recognize that kind of sound. And then back in the UK, sort of 10 years later, we've got like a kind of stuff, right? It's the same sample, just fast. But they wouldn't just change the rate like this. They would also do things like use this magic scissors and chop up the sample to every kind of drum. And this seemed like a really interesting thing to me to be able to do. But of course, like the magic scissors was really looking at a visual waveform, seeing where the transients were, where the energy was going from low to high, which essentially meant like low, then high, then low, high. And then you would put the magic scissors around that, and then you would then cut and paste it out into different order. Kind of like if you were to get a newspaper, you might chop up all the words out and then rearrange them to say something completely different that the newspaper didn't say. Same kind of thing. So of course that's not in the computer science curriculum. The teachers are not going to let you teach that. But options like that's not far off, right? Be able to change the parameters of things. So I thought about this. And I thought it would be really cool to be able to like do this, where you can treat the sample as an array. And you could iterate, work through all the different sort of indexes of all the transient sounds. So this does automatic feature detection on the audio wave file. It then returns back a list of all the transients, which it caches locally, and then you can treat the sample like an array. My brain did it in reverse there, which is super fun. So if I put this into a live loop, and I sleep for 0.25 seconds, I can then start to, I need to give it a name. So it's called beats. Cool. But I can like totally change this. Or, oh yeah, we're getting there. Again, you start to modify these things and play around with it. And so you can get to something interesting really, really quickly. And the cool thing about this technique is it doesn't just work for drums. Let's go back to this. I can delete that and make it longer. And I can switch it. Switch it in for a guitar sample, and I can use whatever samples I want. Or I can take a sample of like I do this for fun.
We can create.
That's Rich Hickey talking. Let's get him talking. Let's comment this out and comment this out.
We can create.
Someone talking about computer science, good old Rich. And we can take Rich and use him as an instrument. So let's go for onset, tick. It's a local thread local counter, which is going to tick through all the different onsets. I'm going to sleep for 1.125 seconds, and then
we can create precisely the same program. We're creating now these tools complexity with dramatically similar tools. Right? I did C++ for creating not
now, so I mess around with him, make him into a chipmunk.
With electrical
or low. Or I can start doing things like
creating a program, and I leave right now, and I create I did languages, like I did not, and 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 I did
yeah, poor Rich.
And I did not, 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 and I did
and they have a lot of fun, right? Again, slicing up the samples, messing around, and just treating them like an array. And it's important to point out that everything I've shown you so far, all the constructs inside Sonic Pi, I have, and others have, effectively taught to 10-year-old kids. And that's a critical thing. And this is a really an important thing I want to talk to you about. Because obviously that was a requirement, right? It was a hard requirement. I'm going to build some software to go into schools. So it better be simple enough for teachers and kids to work with, right? And I would also like to extend this idea to any software that you might write as well. Because if you think that your software isn't simple enough to teach your 10-year-old child, then maybe you haven't thought about it enough. Think about it. So this system has got concurrency, it's got mutability, it's got network messages, it's got events, it's got a CRDT system. This thing on here, the pink and the orange, is an internal in-memory CRDT database which stores a fully ordered list of all the events that go in, which is deterministic. The reason why it needs that is it uses Lamport clocks essentially to order all the messages internally. I've spent a lot of time, obviously, having to think about how to simplify that stuff so that I could put it into the system. Now, the benefit of that is obviously that I could meet my criteria of going into a school and using it. But the side effects of that are profound. There's been so many situations where I personally have had benefit. I've seen other people have benefit because of that simplicity that I hadn't even imagined. So, let's look at one scenario where you've got a child, they're sitting at a computer, they've made an error, there's a bug, there's an error, and the teacher comes over, and the teacher doesn't really, because most teachers in the UK haven't got a degree in computer science, so they're all winging it, trying their best to muddle their way through this. And so they come up to the error, and they're like, oh, I don't know how to fix this. It's all cryptic stuff, you know? I mean, like it was when I did Clojure code, and you got all this Java stack trace. How do you understand that? So obviously I put a ton of effort into trying to simplify that and to make that easy for the teacher to help, for the student not even necessarily need the teacher. Turns out that me, after a few pints of beer, at 2 o'clock in the morning in a nightclub, using the same system, have a similar kind of situation to that school where my cognitive load is maxed out, right? I'm super stressed. I'm trying to plug things in. The audience is there expecting something, and I've made a bug. I haven't got 5 minutes to fix it. I haven't got 1 minute to fix it. I probably haven't even got 10 seconds to fix it before people are annoyed. So having put all the effort into making it simple in the classroom has paid dividends back to me performing in a nightclub. And similarly, across the spectrum of all these kind of improvements, and this includes all accessibility improvements. So I've made sure Sonic Pi can work with screen readers. I've got color schemes that are high contrast, so people with low vision can work with it. And that sounds great. It's great to open up the world of, especially music, where predominantly music software is clicking on pictures, which is annoying for blind people because they can't see the pictures. Why can't they write their code with words? Because then screen readers can work with that. That's brilliant. But even if you've got a color scheme which has got high contrast, that obviously is very useful for people with low vision. But if you go to do a talk in a school where they've got a really crappy projector, a really old projector, the bulb is sort of flickering off, the screen's not very good, the lighting's not very good for it, and you project this kind of stuff, it's just not visible. Like the black is not there. So you put it in the high contrast mode, suddenly you can use the projector in the school room. So again, doing things for accessibility really, really helps you in profound ways that you hadn't previously imagined. So, all that to say, Sonic Pi is fun. It can help you make friends at parties. It can help you understand that computing is not just a tool for business, it's a tool for human expression. And I would really like to invite you to have a play with it. Obviously, you can read the mathematics, but go to the website. And if you're a company and you like what I'm doing, please consider sponsoring me, because I don't charge for the software. I'm fully self-supported, and so the only way I can continue working on this is by sponsorship, by individuals. So I have a Patreon that people are donating towards. A GitHub sponsor is also a critical thing. So if you really want to support what I'm doing and like what I'm doing, please consider that. And then join our community. We have a cool community of people. This is a community of not just programmers, but artists, teachers, educators of all kind, just people just interested in tinkering around, sharing their work and ideas, asking really interesting questions. And that's really a beautiful thing to be part of. And if you're into education, we have a ton of materials to get in the classroom to get started. I've got a book you can download and read, and you can watch exactly the same talk I'm giving to you in the past and play around with it and see the kind of cool things we're doing. And I'll finish off by talking about one of the most exciting things that ever happened. I mean, two exciting things. One is I got onto the Rolling Stone magazine. I did a performance in America at a Moog Fest, and there was only 2 artists in the whole of this Moog Fest they mentioned in a positive way in this review. It was me and Grimes. So if you want to be mentioned with Grimes, then get live coding. And and the other thing that was really cool was that we got into there was a group of kids learning how to code in a school context where all these schools are going to join together and form a mega orchestra, like 5 orchestras, 4 wind bands, a drumming circle, 3 choirs. And they all joined together and they got into the Royal Albert Hall and did this amazing performance. And part of that was me and a Sonic Pi teacher and 2 Sonic Pi live coders. And I have to find a picture, I had it in my folder somewhere. Here we are. So this is us in a musical context in the Royal Albert Hall, with traditional instruments and code on the top. It was funny because a lot of the kids there were playing their traditional instruments were looking at the 2 kids that I was working with and going, oh, they've got synthesizers. They can make crazy sounds. And it was such a beautiful experience. And where are we? There's me now going, hey! And this is the picture of us after our performance. And we had a really fabulous time. And so, yes, this is, again, a way to sort of reframe what computer science is, the venues that you can actually talk about computer science and share it with other people, and the kind of impacts you can have when you make and reframe computer science in a way that's meaningful to the other 95% of people who aren't in this room, who wouldn't choose to be in this room. And to me, that's really a critical part of our adventure together to figure out how to actually get more people programming. If you've got companies that are desperate for more programmers, you'll feel this really strongly as well. And so we need to find ways to engage that next generation. And I honestly believe that making code creative, making it meaningful to individuals, and showing people that they can express themselves through code in new ways, I think is a really important way to go. So thank you very much for your time.